Hello again, Ivan. Ivan is going to be a leader of the discussion panel about routing around Catastrophe. On left side it's Łukasz, then Adam and David, but they will introduce themselves alone, I think. Okay, let's start. The floor is yours.
Thank you. So I am Ivan Pepelnjak, a grumpy old network engineer that always complains about what the vendors are doing. And luckily I have two vendors sitting here. And I'll be soft on you.
I have to leave right now.
So, well, let's start on the other side. So if you would introduce yourself.
Okay, Łukasz Bromirski, Technical Director at Cisco Systems Poland.
Adam Grodecki, I'm Solution Manager at Huawei, Poland.
And I'm David Freedman, I'm Network Manager at Claranet Group.
And the topic of today's panel is how do we route around catastrophes? So we have the fat fingers of network operators. We have people deliberately hijacking other people's prefixes. And it was a big deal in, what was that, 2008 or 2010 when YouTube was hijacked globally from Pakistan because of fat fingers and upstream provider not doing their job. And there were a few other incidents, and then it all got quiet. So when I was talking with David yesterday, he said, well, no, it got better, but we are still far from doing well. And so I asked him to prepare a brief overview of what was going on in the last few years. So please, David.
So, if I can just stand up, thank you very much, Ivan. I've participated in a number of these sessions about routing security. And the very first thing that has been mentioned is the YouTube Pakistan telecom incident of 2008. Now, I'm fed up of hearing about this because it's so old, and yet people seem to keep using it as an example. So when Ivan approached me and said, what's going on? I said, well, not much. Actually, I don't really recall anything happening since that incident in 2008. It's been really quiet. And then I went home and I had to think about that. I thought, has it really been quiet? Has anything really happened since 2008? I'm sure things have, maybe I don't remember them. So there are these projects that measure routing reachability information, such as the right RIS and the commercial providers such as Renesys, and they provide reports on it. And then there's bgpmon.net. That's very interesting. For people that aren't familiar with bgpmon.net, there's a chap, Andre Tunk, who wrote a piece of software a couple of years ago. And what that does is provide monitoring and alerting based on prefixes that are that people have registered to them, or AESs that are registered to people. And whenever these change, if there's a potential hijack, you get a little alert. It's a nice little system. But one of the interesting things Andre does is actually whenever alarms are sent to people, he looks back at that data to see whether those alarms were meaningful or not. So you might hear of hijackings occurring on the blogs of the RIPE NCC for the RIS service and on Renesys. But these only happen when there were big notable incidents. The beauty of bgpmon.net is that Andre actually documents these as they happen based on alarms that are sent to users. So I went back to look at Andre's blog, and this is what I found. Now, I'm going to go through these incidents very briefly, and I'm going to start from the top left. Now, I'd like people to raise their hands. Can you tell me what the flag of this country is? First person. Brazil? Yes, good. In 2008, the same year as the YouTube Pakistan telecom incident, in the November, there was a leak in Brazil. It lasted about 20 minutes. There was about 260,000 prefixes, and it was possibly an error. And we use this term fat finger. The fat finger is, of course, the finger that, as it puts its finger on the keyboard, presses more than one key at the same time.
Was that the size of a routing table?
Well, it possibly was at that time. I personally thought, just from memory, that we were closer to 300K, but it's possible that they didn't have a full table. I'll get onto that in a minute. So let's, next country, next flag, the blue and yellow. Where's that? Good. So in 2009, there was a 73-minute incident where, again, around 260K prefixes were leaked, and that was probably an error. Not much impact. So the following year, where's that flag from? Good. In 2009 again, there was a 2-minute 85K prefix leak. Again, possibly an error. Next flag. China, good. 15 minutes long, 37k prefixes. Now, initially, there was some suspicion about this one because it had happened the week previously. But on conclusion, if you looked at all the data, it was probably an error. Next flag. That's right, it's Indonesia. And in fact, it's the Polish flag upside down. I thought I might catch somebody out there. That was 38 minutes long, Indosat, I think it was, and that was 2,000 prefixes, again an error. And final flag, Canada, that's right. 30 minutes, that was a full table, and that was most certainly an error because it affected Bell Canada, the national incumbent, and many people on Nano were not happy. So that's about one error a year, and it was probably a human error in most cases. But then there's 2013. In 2013, a company providing spam filtering called Spamhaus were famously attacked, and a denial of service protection provider, Cloudflare, were in the news for defending against this attack and for it being a very large volume. What a lot of people don't know, unless they were attentive, is that prior to this attack occurring, it was noted that on the NLIX, an internet exchange in the Netherlands, somebody tried to leak the prefixes from Spamhaus in order to redirect the traffic away, we think. Without naming names, and if you use images.google.com, you can possibly see who this was. The hint is look towards the right, at the bottom. So that's it. Since 2008, only one possible hint of malice, and actually this NLIX incident was picked up and really not listened to by many people. It didn't cause much of an impact at all. So going back to this slide, mainly misconfigurations, not very often, and the one time somebody does try and do something that's slightly malicious, well, if I can get to this, doesn't have much of an impact. That's where we are at the moment. A lot of hype. Yes, there's been error, but not much else going on. Thank you.
Thank you. So, if we take a look at these figures, is everything okay in BGP land, or is this just quiet before the storm?
Depends if you think there's going to be a storm or not. It depends what you're worried about, really. I'm sure there are people here that think that they offer an SLA on internet traffic. If you offer an SLA on internet traffic, that means you need a degree of robustness and a chain of contract that allows you to do such a thing. Or you take a massive risk. And a bunch of people in this room as operators, I'm sure you do take a massive risk. Is what I've just shown you evidence that the system is not particularly robust? I don't have the answer to that question. But I do know that from my personal perspective, it's not as bad as I thought.
Thank you. Now, if we turn over to the vendors, most of the time we have to do whatever we have to do to protect ourselves and our neighbors by configuring filters on the boxes in one way or the other. And most of that is manual or semi-manual or semi-orchestrated thing, usually relying on a bunch of Perl scripts. So is there anything being done on the vendor side to make these things easier for the operators?
So move to Tickle.
Oh yeah, apart from Tickle scripts, yeah.
Oh, you got me. So nothing. Okay, so maybe I'll start. I think that the industry is moving into a kind of automation, but from the engineering point of view, we are kind of defying taking all the toys from us in terms of configuring something on the devices themselves. And of course, we can add some additional layer of aggregation or additional layer of information on top of that in part by just moving into the SDN space, but let's leave it. I think from a technical point of view, two things that are currently pretty important is, first of all, is the CIDR, so Secure Inter-Domain Routing Initiative, that in some point in time, in future, of course, not right now, will enable us to kind of automatically filter the information or at least decide if we want to accept it or not. And it should it won't resolve all the problems David mentioned, but I think that in some areas it will improve the time to recover from the problem. The second point is also something that David already witnessed by the RIPE panel on the last meeting, and it's interesting because we had on the last session in another room we had a discussion about DDoS attacks, and out of the 70 people in the room, when we asked about the BCP38, which is spoofing best practice, only 2 people representing the service network operators raised their hands that they are trying to implement this. So spoofing is completely another story that needs to be automated. Recently we've got, I don't know what is the situation with the other vendors, but recently we implemented the solution to adjust for the spoofing for the MPLS VPN labels in the inter-OS scenarios. So you get some automation out of it. So I think from my perspective, I would mention those 2 mechanisms to kind of help with the automation of the network traffic information and network prefixes.
My point of view is a little different, let's say.
Okay.
Of course.
Basically, we are looking at the security of the internet access and other services from the totally different perspective than just the network resource exhaustion or some changes of the network configuration. First of all, it's a kind of a question. I like so much these slides you had, but according to the recent, let's say, data I checked, kind of this attack is around 1% of the total attacks. You know which layer of attacks today is the most headache of all the operators, and they really cannot do anything with it, and it's causing really insufficiency of the calculation of the customer equipment. So it's exhaustion of the, let's say, computing power. Which layer is the attack, do you think? So it's actually between layer 5 and 7, and we have 88% of such an attack. It's a headache for those who wants to implement really cloud services. This is the biggest. 75% of the enterprises are pointing the number one problem is the security of those layers in implementing cloud services. So basically, we look at its perspective from totally different point. We don't analyze only this kind of a network mechanism, network resource exhaustion, no only anti-spoofing kind of mechanisms, but basically the most important, we think, is the user behavior analysis. So what Huawei is doing really in this domain is try to connect as much as possible the user, not ID, but let's say user interface within the session that the user is doing. This is what we believe the most important, not only from the fixed type of environment, but also for this kind of a convergent. Why? Because first thing we have in the global scale of internet is we introduce a lot of smartphones. Those smartphones are going to kill soon by the LTE network any kind of a core which is not prepared for a signalization storm. To do it, you need the good MMEs in front of your SGSN, GGSN to defend your resources of the network. This is the first thing. Second thing, how you are going to track this user when he's changing from the BRAS domain to the GGSN and there and back. This is basically the thing. We have since 2 years constructed something what we call security gateway backend solution. When we actually track the user location or interface within his profile of a security behavior, and we create such a template which user also can change, which is a good product to sell, and we have already a very good references, such as, for example, TokTok in UK, when we sell as security as a service to the end user. So thanks to backend and the front end, which doesn't need any more manual configuration, adaptation, and blah, 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 stuff like that, this backend is doing the whole job on the front end firewall to adjust your network to have the user secure. So this is basically the change we are doing, and this is a little different than just looking at the network mechanisms perspective, rather the user behavior.
So, can I just ask a question there, Adam? You talked about security as a service. I'm interested in providing internet as a service.
Yes.
And when I've got a user that can't reach something because the destination is no longer the destination, that's a problem. I can't deal with that. It's beyond the domain of my control.
This is what is basically the most important during the phase of a backend configuration. We decide how the introduction of DNSs and all the updates are going to happen. This is first time. So we are actually tracking even the content changes on the filter, very high performance hardware, which is tracking all the changes in all the updates that are going to the internet site. And if the user is going the same way to the same pattern, and we can somehow within the operator track. But we are doing this not only per operator base, this is the most important, because our backend solution is working globally based. So we are giving this possibility to the operators to use our DNS and kind of a malicious code detection global scanning engine, which is somehow checking where is the problem in the world, and how to defend that, and how to change the policy in the network, how to change DNS updates, how to change the firewall rules, and etc. This is the thing.
But when a network the other side of the world is hijacked away, taken away and replaced by another network, what can you possibly do about that?
Yes, this is
even if the result of that is you just can't reach them anymore, what do you do about that? What do you do when your customer says, I can't visit this website?
This is a kind of a question we go a next step. What is happening when you want to do a service within not your sphere of influence, yeah? And
Exactly.
This is a totally next question. However, if you can think like global-wise, you will have more and more information exchange about what really is going on inside the network. Somehow you can track globally what the problem is. And
Yeah,
you can,
this is what operators do in the internet today. There's a leak, there's a hijack, and it becomes known, then everybody jumps on top of it, and the reaction is usually very fast, unless one of the operators involved is a large carrier. And then it goes into the tar pit, because that's almost entirely in the carrier's domain, and they won't help you because you're not their customer.
And this is the coming, somehow the vendors actually, to be honest, because we are creating a tool to monitor this thing, and this is the global tool. So within this tool, we have somehow a map of the problems, and we as a vendor, we want to fix it, and our customer is the carrier. So we really want to fast detect this, because we have many carriers who are coming to us and asking, man, guy, I'm selling security as a service, and your actually platform, which is backend, is not really functioning. So I have to fix it.
So your service will intermediate data between carriers. That sounds amazing.
Yes. This is what we are doing actually currently. We are not intermediate, but exactly we are building the kind of database that helping us to analyze the problems. Yes, and within this kind of approach, you can check the TokTok, for example, reference. You can check the Turk Telecom, which implemented this kind of solutions, yeah? And this can be kind of a good going deep study, what's really happening in there, what we are doing.
Huh. So, Łukasz, what's your response to this?
Well, I would love to sell some products here, but I will avoid this. We have a lot of services running in the cloud. Some of the services supposedly protect you from the attacks, protect you from the availability and unavailability problems. But I don't think that any service can protect you from the things we are talking right now, because I understood that we are discussing infrastructure problems and communication problems between the commercial entities and vendors and other organizations. So, if we start from the people that are managing the devices and we focus on that, and then go to the clouds and to the service delivery programs and products that we can sell, I think that we have to meet in the midpoint to discuss the things that we can change or that we can influence. Because of course we can sell something. We also have some amazing products that we can position. But the truth, unfortunate truth, is that the problems lies not in the way we sell the products or we buy the products, but in the way the internet is built.
Yeah, I think I agree.
I totally agree. So what are you doing to fix that?
I'm at the Pepelnjak.
Okay.
Well, go ahead.
Yeah. Go on, sorry.
So I think that the first point is education, because we started the Pepelnjak to also have the platform to educate the customers, meaning service providers, to actually implement the best current practices. We are a long way to go because, as I mentioned a moment ago, BCP 38 seems not to be so widely deployed in Poland as we thought it should be. And we have a long way to go because right now Poland is hit by the flood of the DDoS attacks, and we are fighting with that kind of threats. In the meantime, we are dealing also with the customer problems that hit the kind of management plane of the discussion. So things like fat fingers, things like automation processes that went wild and reconfigured most of the DWDM network, for example, in one of the carriers. So education is the first point. The second point is, of course, to try to deploy or try to develop bulletproof mechanisms, which we are, as we know, there are none. But we are trying to do that. At least we are discussing this with the customers and discussing this in the wider community, how to do things differently to avoid that kind of mistakes.
If I just stay with your anti-spoofing disaster, lack of it, to be precise, we all know it's almost impossible to do something sensible once you're transit because of asymmetrical routing. On the other hand, this should really be the job of the access providers, where it's really easy because you only have one single path to one single customer and there is no multipathing and asymmetrical routing and so on. So why do you think people are not doing that? I mean, it's just one command on the box.
May I?
Yeah, go ahead.
Okay, so that's an interesting point you make there about it being the responsibility of the access provider. It is most certainly the responsibility of the access provider, even if the customer is multi-homed. And this is where we run into issues, because in residential access, customers aren't multi-homed. They have one piece of string from your central office to their premises, and that's it. They don't usually have anything better than that. Unless they're a business-grade customer, they want some kind of resilience. And therein lies the problem, because multi-homing doesn't necessarily mean the customer only has two paths. It can mean the customer has multiple paths. And in BCP 38, there is no means to disambiguate between those paths. So BCP 84 introduced this concept of feasible RPF. FRPF, and FRPF was I think a goal whereby every feasible path would be permitted. The problem we've got in modern networks is it's not possible to know about every feasible path without something like, say, for instance, SDN, because modern networks that are dynamic and based on routing protocols need to have a global view of which path can be selected at any one point in a central place in order to do that. And on the edges, they can't. So FRPF is a bit of a myth at the moment. So in networks where you've got this sort of large degree of multi-homing going on, you're doing something, you then go off and you put something custom down like an ACL. But let's get back to basics here. The purpose of BCP 38 was not really to force people down the URPF path. It was just to make people do the source filtering, and I think that message has been lost. The fact that you can't use a technology like URPF to prevent spoofing coming from your customer base doesn't mean that you're not doing BCP 38, because the real message behind BCP 38 was that you should filter the source of packets coming from customers. And if you can achieve that with an ACL, well, that's what we had before the URPF came about. That's the real message, and nobody's even doing that. They're saying it's a problem too hard for us to solve, we don't have a FRPF, we think it'll break things, or we just don't care. And it's one of those. It always falls into one of those.
It's always
buckets.
the last one, I think.
Yeah, it's always the don't
I think
care.
I have to defend a little the operators for this point. Sorry. But since 3 years in Poland, we have this kind of experience and discussion that the customer would like to follow the one single customer with the one single ACL. And you know what's the problem operators have today? They can't follow. Because this customer is just changing. He's changing resources, he's changing platform. Sometimes this is like this customer is today is mobile, tomorrow is fixed, and he wants the conversions and etc. And yeah, you shocked, you look like, wow, what's the problem? It's no issue. But those are sometimes within one operators. There are 2-3 micro organizations. Those guys don't exchange resources sometimes, etc. So this is the kind of a problem we are having in terms of organization. So it's not only the technical issue, but also the kind of a structure of the companies inside. So this is the problem what I see since 3 years in Poland.
But that would mean that these micro-organisations are missing either documentation or a proper onboarding process to capture that documentation about what the customer uses.
Yes,
if that's really the case, they shouldn't be operating. That's a bad operating model.
Yes, but yes, I agree with you 100%, but this is reality, and somehow this is the vendors who should help operators to fix that with some brilliant solutions and etc. And those sometimes require lots of additional software or something like that. Yeah, this is the case.
Okay, so allow me to jump in there. I mean, I totally agree with you. For multi-homed customers, RPF is a nightmare. Now, if we take a look at how much of the address space in internet is actually multi-homed and how much of that is residential, where it is always single-homed, and how many spoofing attacks you get from multi-homed customers versus residential customers. I mean, I haven't seen any data, but my gut feeling would tell me that if we just implement URPF on residential customers, we would get rid of like 80% of the problem.
Yeah, there's another problem here, which is the fact that today we've got lots more NATs in the core. Okay, and these NATs are devices that are put towards the core, away from the access. The access has got some kind of, private or NAT addressing. The NATs are in the core. The NATs themselves are multi-homed. In fact, the NATs are probably anycasted these days. So you don't actually know which NAT device is going to originate a packet from where on behalf of which user. And that's a problem. That's a problem for the NATs, and it's not a problem for the network.
Yeah, but if you're doing NAT, and if you're a service provider, then behind the NAT you have some private addressing scheme.
Yeah. But you don't care about the state. If somebody's spoofing packets outbound, the NAT will say, oh, I'm not going to keep state for this, I might just transmit it, but I'm not. And a number of NATs do that.
Yeah, but you could do RPF on the private part, can't you?
Sure, you could do that.
Boxes.
Yeah, lots of boxes.
So you're saying it's basically unsolvable?
No, not at all. Just filters. Just implement filters. Just standard filters. No fancy RPF, just filters. You can do it. Just have to do it manually or get somebody to write you some automation or buy some. It can be done. RPF doesn't solve every problem. It solves a really basic use case where you can't be bothered to configure an ACL on a single home customer with a very simple configuration, yes. Oh, no, and loose URPF, of course, solves the problem where it allows you to filter sources on demand on ingress at the edge of the network, but that's about it. In fact, loose URPF now is becoming more useful than strict in that regard, I would say.
Yeah, so I think we need to educate, train, and then have some carrot, because right now we have only a stick.
Yes. It's the stick. That's what's important.
By the way, the comment you made saying that, well, if they can't get that together, they shouldn't be ISPs. So do you think we should have something like driver's license for the internet?
It should be called a peering license. You should need one to peer, I think. Of course, that won't stop you buying transit, but then, your upstreams will not be happy with you.
I think that the carrot for the operators will be really the thing that they can sell a service. This is the only carrot they can have. And the service can be only the kind of, what I said at the beginning, security as a service which they can sell. This is the carrot. Because the owner of the project has to have money, has to have budget. This is exactly the situation of the operators inside. So we as a vendor, we have to give them not only education and knowledge, but also the information to all the marketing department. Hi guys, here's the nice services you can introduce and get some, maybe not money, maybe you can reduce your churn. Because maybe you will be more secure than others, and the guys will stay with you than with others, something like that.
I can't imagine what that would look like, because it's like saying I've got a certificate which proves that my users are my users. I mean, what value is that in a sales process, that I know who my customers are? It'd have to be something stronger than that, like a certification. You know, it would have to be something that became mandated in the industry, and we don't have an industry-sweeping certification to carry something like that on at the moment. We only have a stick right now. We don't have that carrot. We need to find it.
Well,
and it probably won't turn out to be a carrot at all. It'll probably be a beetroot.
So what I said at the beginning, for the end users, they can have even their own service kind of a management portal. And I'm sorry, I'm not selling the product. It's just an idea. You can guys do it. It's simple. We are allowing to the end user of the operator to change the policy he has applied to his connectivity. That's it. It's very easy. On the website, I'm the parent, my children are not allowed to do this and that.
I'm the parent, my children are allowed to spoof. Is this what you're saying, whether the connection should be allowed to spoof or not?
Not spoof, just I'm deciding what is allowed in my house or not, and that's it. And this is the nice thing, that the user can say, oh, wow, I have an operator who is giving me chance to manage something I haven't been even aware before I can manage. And this is like a www portal only. It's a simple thing.
So you're saying that they should hide that investment in what looks like a value-added service?
It is very nice. We have already references that it worked for some operators, and it's really worked nice. And it's not so stupid, believe me.
David, one carrot you could get out of that is if someone starts sending spoofed packets with spoofed IP addresses, well, either he's malicious, in which case there's nothing you can do, or he's infected.
Or he's misconfigured.
Yeah, in which case you can inform him.
How do I know who he is?
Pardon?
How do I know who they are? I might just receive packets from a peer.
No. If you're the residential ISP.
Right, and I receive packets from a customer circuit that aren't their own.
Yeah. And if you have the access list in place and logging and analysis, you can actually tell which one of your customers is infected.
If I have that level of logging and analysis, then other people will want that data.
Exactly.
So I don't.
That's why we have created this so big backend to have all this data, and you can really share this and analyze this. And the malicious code is one of the key things you can analyze.
Isn't there another three-letter acronym organization in the US that had such a big backend full of data?
No.
Where you can analyze this.
We are not connecting this to the username and etc. such as thing. Yeah, that's why I said it's a very here. Also, this is the kind of issue, and we have to really understand.
Sure.
Either we want to really fight with the security issues or collect data, big data. This is the big, what we want to do, and we have really be careful not to convince operators this is a part of a big data collection, because we get them scared, and they will not will to do it because they will be afraid about the opinion they are actually collecting too much. This is also very important to be very careful and keep this border. This is only collection of security and connectivity and behavior, etc. No relations to the big data analytics. This is very important.
I was just going to say, I actually know of an operator who manufactures their own CPE. They have their own set-top boxes that provide internet access. And these things have an option of, which comes turned on by default, of doing some kind of malware signature analysis on the traffic, including looking for supposedly spoofed packets. When it sees them, it alerts the operator puts the user into a walled garden, and they get a nice message saying, your PC is probably infected, go and fix it. And that's good, it's CPU driven, and it doesn't appear scary because the operator's not doing it in the network core, it's just done on the CPU, you can turn it off. I don't think it's feasible to do that on the network core. Really. I don't think it's feasible to do that at the access layer, to have that level of logging enabled, because that logging is the slippery slope to more logging until you have this big data and it's there. You can't feasibly turn around and tell people that you don't have it.
Yeah, but that kind of service is, of course, very beneficial for the access providers or for the residential providers, unless, of course, the customers decide after getting that kind of message to change the provider.
Yes.
And this is, of course, also the carrot for the access provider in terms of his access, but this is not a carrot for him to provide to the tier 1 or tier 2 service providers. So I think that the question should be rephrased. What can we as an industry offer to the service providers that are actually not happy with any carrot we can give them right now to provide that kind of the services?
Yeah, and that's the usual problem we have on the internet, where someone would have to invest, like the access providers, and someone else would actually benefit, which is the content providers that wouldn't get the spoofed denial of service attacks.
Well, actually, I think one thing that we haven't mentioned, which is interesting, is that we're seeing less and less of this coming from residential connections these days. More of this comes from hosted servers, the cloud. A lot of this comes from servers sitting in data centers that are themselves multi-homed because they have two sort of pair of redundant devices in front of them acting as a gateway.
And they have NAT, they have various IPv6 boxes and things like that do the transition, yes.
Yeah, and now that we mentioned denial of service attacks, also, the brute force denial of service attacks aren't that efficient anymore. Because anyone who is really exposed has a scrubbing service in front of him. So you can throw all the traffic you want at him, and that won't help.
Scrubbing service or a CDN.
Yeah.
And the CDN just sits there and absorbs.
Exactly. And if you're trying to spoof the packets, then you can't run things like slow loris attack, which really hurts. So yeah, I'm sort of agreeing with you that you will see less and less spoofed packets because they are not as efficient as they were before. Okay, now if we move forward, so there's the RPKI that you mentioned, and yes, it will help once everyone implements it. So, first question, will everyone implement it, or will US claim it should be based on DNS?
Well, I've got another opinion on this RPKI issue. So a number of years ago, at a RIPE meeting, there was a lot of concern that the RIPE community and the RIPE NCC actually were acting towards producing a system that supported and enabled the RPKI. And that this worried a lot of people because, of course, the RIPE NCC being a Dutch company and subject to Dutch law, it meant that somebody could come to a Dutch court and ask a Dutch judge to tell the NCC to revoke or remove or alter in some way something in the RPKI. And that meant that that was an easy way in for a foreign jurisdiction to do this. Anyway, to cut a long story short, the fact is that since CIDR work has started to happen in the IETF, vendors attending the CIDR working group have been walking away thinking, I'm going to implement this and I'm going to make it as easy as possible for users to use because looking at this stuff on paper seems very hard. So I will implement a simple knob to turn on and off RPKI to point it at cache and it will be very, very easy. And when it's easy, of course, I say like URPF, of course that's perhaps a bad example, but when it's easy, it's generally done. If it can be a tick in a box in a security certification, it's generally done. And that then leads to an adoption, I feel, of RPKI in the wider community as a whole. Now, I've had this argument with a number of people, and some actually refute this, and they say no, they wouldn't just turn it on, and it would go like URPF, and everybody would talk about it, but never actually do it, and then 10 years later, there'd be a show of hands, and one person would have their hand up. But it may happen. You make something easy to do, you tell enough people to do it, they'll do it. Eventually. Might not be quick, but it will get done. There'll be parts of the internet with RPKI enabled because some vendor gave them a button that they just have to press and it works.
Yes, and you see the adoption rising actually in the statistics. I've just looked it up before the session. It seems that in the RIPE region we have like 10% of the resources certified. In the LACNIC we have close to 20%, so this is moving forward. The question is, of course, if the RPKI is not the best solution, but I agree with you. If something is simple, it should be easy deployable. Question is, do we have something better than this? But given the last 10 years of the discussion around the BGP securing intents and all, I don't think so.
So the thing about the RPKI and SBGP is it really helps only with origin validation. So whilst it prevents you from spoofing an address from the wrong origin, all you need to do is fake the correct origin and send the traffic anyway. So then you have to go to the next level. You need SBGP, you need the AS path validation. But then, if you spoof the AS path, you can still originate the traffic. So we're back again at the data plane, and we're back at spoofing. Okay, it's great being able to divert traffic away with routing hijacks. But at the end of the day, unless you tackle the routing and the forwarding planes together, you'll really, one thing will pull against the other, and you're not going to move further forward on this problem.
Yeah, but actually coupling those informations, because IS path validation and prefix validation is part of the CIDR. So if you couple this together and then you add the certificate, that is harder to spoof or to fake than just the IP address in the IP header, I think you are raising the bar for the people that will try to do it maliciously, or will try to do it because they made an error, because they, for example, signed the certificate.
But I think it's interesting that the entire system has been developed such that it suits very nicely against the people trying to do something maliciously. And it's not really a system that, yes, of course it prevents error because the configuration is invalid, but it's like we haven't thought about tools that we can use to minimize error from the operator's perspective.
Yes, but that's the way Internet was built.
Yes.
It's based on trust.
Yeah, exactly.
Trust.
But I think that operators could help by reducing the amount of possibly human error that could take place on some of these internet-facing boxes.
So let's add additional level of indirection, SDN.
Well, no, very simple things. Very simple things such as a CLI saying you're about to do something that looks very, very stupid. Are you sure you want to do this?
We are adding that kind of warning messages, but the feedback from the service provider community is that they are
annoying,
slowing them down, annoying, yeah.
So let me.
Of course, I know. I want to delete this.
So look,
I know what I'm doing. Why are you stopping me?
I remember configuring BGP peers, and you pasted a number of lines of config, and because it took the router so long to actually get the session up and running and start announcing routes, it was okay because you got your filtering in time. And then one day I bought a big fast box and I pasted a line in, and within a second of pasting the first statement, I already leaked a full table. Thankfully, it wasn't anybody real and on the internet. But the point is that people do that, okay? You have things like maximum prefix filters that you receive on ingress. We don't have one that goes on egress, do we? We don't actually have any way of telling somebody, what you really, really look like you're about to do something stupid here. Please don't do this.
Yes, but again, I think that we are introducing some defaults or some sane defaults into the operating systems that are trying to kind of fight with it. For example, with one of the core routers we have in the offering, essentially with the iOS XR, let's say that from this point of view, for the BGP sessions, we are limiting the number of prefixes by default. So if you want to have full table or more than that, you are more than welcome, but you have to configure it. Just because we are talking with the service provider community and they are telling us, let's do this because it's not good solution for the problem, but it's at least something that is a showstopper for something that you will know, Control-C, Control-V for the terminal. But again, this is not automation. This is something that needs to be manually done.
Yeah, and I see RPKI as being in the same category because it effectively prevents the fat finger incidents like we've seen on your slide. If someone wants to hijack AS path, he can still do that.
It may effectively prohibit, but if everybody or almost everybody will try to use it to make actually the decision about installing it in the table or not. Yeah. Because right now, most of the people that turn up the RPKI just get the cache of the information. They are not making any decisions based on that.
No, they're just trusting a cache.
Yeah.
And they can happily have that cache outsourced. Somebody could run an outsourced RPKI cache and just say, don't have to worry about anything, configure me as a cache, pay me some money, off you go.
Okay, thanks for that nice wrap-up. We are almost out of time, so if there's any question left in the audience, you have 1 minute left.
60 seconds.
Well,
I was wondering if Jan was going to pick up on your May and ask if it's an RFC 2119 May. Now, any serious questions? Anybody?
Not so serious questions?
Damn it, stole my line.
Sorry.
No?
Yeah? Okay.
Well, thank you
very
much.